Hello students, welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Apex Elenio, and in today's video we're going to be looking at one of a four-part series in our factorization video. This in fact is a video that is made primarily to assist CSEC students right across the Caribbean in terms of helping them to comprehensively understand one of the very important branches of algebra. Factorization is a very key component in algebra, and of course it's one of those repetitive questions that comes usually at question 2A and or 2B, mostly on every exam both in January and May. If this is the first time you're coming across the channel, of course I do provide a wide variety of contents, live classes for CSEC students. I do have a TikTok, I do have a Instagram, and I provide behind the scenes on my TikTok as well. So if you guys would like to tune in and log in to, just building students, helping students to develop their confidence, and just of course changing the game, changing the way how students view mathematics, and most importantly teaching you all the language of the universe. Please be sure to do one of four, if not all four things. Hit that like button, it does really help the channel to grow. Hit the subscribe button if you want to be notified. With your favorite content. Please share this out to someone else, some other students, some other friends that you may have that would like to be get some knowledge on the topics that are released on Mathematics Weekly and daily. All right, and of course do not forget to leave your thoughts in the comment section. Now this is in fact part one of a four-part. So in part one we're going to be talking about the fundamentals of factorization, and we're going to be looking at the first method, which is factorization by the HCF method. In part two we're going to be looking at factorization by grouping, which of course this particular video is a prerequisite for factorization by grouping. And after after lesson 1 and lesson 2, then we're going to be using those two skills that we have garnered through practice questions and examples to dive into the quadratic factoring. But before we get to the quadratic factoring, which is part 4, we're going to dive into a very important and exclusive content as it relates to factorizing what is known as the difference of two squares. So tap in and stay tuned, guys. These videos will be coming out daily in the coming week. All right, so we're gonna dive right on in here, and like I said, guys, it is a promise that I make to you here that after watching this entire tutorial, you guys will have a comprehensive and elusive understanding of the concept of factorization. Therefore, going forward, you should not have any problems with factorization. So let's kickstart this video here. Now we're going to be kickstarting by, of course, looking at the definition of factorization. And of course, the term HCF, as a lot of you guys will be already familiar with, stands for the highest common factor. So it implies the highest common factor, which generally means that you are looking to find the highest numerical value that is exactly divisible into a set of numbers without leaving a remainder. But in terms of algebra, or in terms of an algebraic expression, we are therefore going to be looking for the expression with the lowest power. All right, so it gets a little bit tricky because a lot of students over the years that I've been teaching have often just get thrown off by the word highest. And sometimes, depending on your skill level in math, you may find that the word highest can be very ambiguous. So highest in this case means, yes, we're looking for the highest number, but that highest number must be exactly divisible into all the set of numbers. And in terms of algebra, as I stated earlier, it has to be the expression with the lowest power. We're going to be diving in a little bit more as we go through the examples. Now, in order for us to comprehensively understand this, I'm going to take you a little bit back to maybe grade 4, grade 5, perhaps even grade 2, where you would have learned an archaic approach towards finding the HCF. And so numerically, should you ask yourself what is the HCF of 6, 12, and 18, for example, in example number 1 here? Majority of you guys will probably assume that the HCF is in fact going to be 6. Now, very importantly, guys, when you're finding the HCF, remember that the HCF cannot be higher than the lowest number that is in the set. Therefore, my HCF can simply be 6 or a number that is less than 6, like in example number 1. My HCF can be 9 or a number lower than 9, or my LCM, like in example number 3, can be 4 or a number lower than 4. Alright, so of course, the HCF of 6, 12, and 18 would be 6. The more archaic way of actually finding the HCF is to list out all the factors of 6, list out all the factors of 12, list out all the factors of 18, and then we're going to be circling the one that is common and that is repetitive in all three, and we're going to circle the one that is the highest, of course. Now, because we are at this level in math, we don't have the luxury of listing out. At this level, you should have very good timetable skills. Your timetable skills should be a little bit above par. So if you're struggling with your timetable or struggling to figure out what is the HCF of a particular set of numbers, then it means that the root cause of your problem in factorization would be your timetable, and you will have to revisit another lesson before you proceed. Should you have enough knowledge on how to find the HCF, then it's very easy to understand that the HCF of 6, 12, and 18 is 6. Now, very similarly, if we look at finding the HCF of 9, 15, and 21, in this case, our HCF can't be 9 because 9 cannot go into 15, nor can 9 go into 21. So there has to be a number that is less than 9 that is exactly divisible into 9, into 15, and into 6. And naturally, a lot of you guys will perhaps guess that the HCF is in fact 3. Alright, now moving on to example number 3 then, in the fundamental aspect of this video is that we're looking for the HCF of 4, 6, and 10. So with 4, 6, and 10, our HCF cannot be 4 because 4 is not divisible into 6 and it's not divisible into 10. So it has to be a number that's less than 4. Now we could try 3, but 3 is not exactly divisible into 4, nor is it divisible into 10. So there has to be a number less than 3, which in this case, by now you guys should guess that the HCF is in fact going to be 2. Alright, so numerically then, that's just a quick little reminder of something that you guys should already know. Now, here's where it gets a little bit tricky when it comes to finding the HCF, is when it becomes, when it's now written in an algebraic form, a variable form. Now, it's very simple. It's actually simpler than what you guys may be thinking, where the HCF is quite easy to find when it comes to an algebraic expression, because the algebraic expression with the lowest power has to be the HCF. Now you might find it a little bit contradicting, because if I'm looking for the HCF, why is it that x4 is not the HCF since it's the highest term? Again, as we stated earlier, the word highest has a little bit of ambiguity because the HCF has to be able to go into the other terms without leaving a remainder. Now, please note that x4 can go into x2, but your result is going to be x to the negative 2. We don't want a negative power to be our remainder. What we want is a positive number to be our remainder. So algebraically, it is possible to divide x2 by x4, but like I said, we don't want our remainder to be a negative power. All right, well, at least at the CSEC level, we're always looking for our remainders to be a positive power. So in this case then, we are obviously going to go ahead and just erase here. So therefore then, if we look now at x2 then, if we look at, say here, just a second guys, if we look at x2, you will find then that, let me grab a pen here. If you look at x2, then it's clear that x4 divided by x2, according to the laws of indices, we are going to subtract the power. So therefore 4 take away 2 will leave us with a positive power of x2. Now, what I normally tell my students, just to simplify the concept, is simply that if we have 4 x's, can we extract 2 x's from it? Now, technically what this means is that x to the 4 implies x multiplied by x multiplied by x multiplied by x, and then we're going to be dividing this then by x multiplied by x. So therefore this x will cancel this x will cancel this x. We are therefore left with 2 x's at the top, and once the remainder is at the top, then the amount of x's that is left will be your power. So that's going to be x squared. So technically that's what's really going on when we are dividing. Now advanced or intermediate students will simply use the laws of indices and recognize that x4 divided by x2 is going to be x2, x4 divided by x3 divided by x2 is going to be leave with x, and x2 divided by itself will leave us with 1. So therefore it's very, very clear that our HCF in this case then is in fact x squared. All right. And since with that very elaborate explanation, then we can simply understand that the HCF in row number 2 here, y5, y2, and there we can see this y doesn't have a power. But a lot of my students and past students will know that should you see a variable without a power or a visible power, then the power understood is a 1. Therefore, our HCF in terms of the algebraic expression here is going to be y. And then finally then, like I said earlier, you are rarely ever going to get an expression at the CSEC level where the HCF or the terms have a negative power. But like I said, the HCF, regardless of whatever terms you may have, is going to be the expression with the lowest power. So in this case, we have p raised to the negative 1, p raised to the negative 2, and p, which is very similar to the y that we had at the top. This is p to the 1. Now, which of those numbers are the lowest? You might be thinking that p to the 1 is the lowest, because you're thinking that 1 may be higher than -2 or whatever the case is. Remember that if a number is negative, then the larger the number is when there is a negative sign, is the smaller the number actually is. Therefore, we can simply look at the fact that the HCF of this particular set of expression is p raised to the -2. Now, should you be able to understand all of what we've just explained there a while ago in terms of the numerical values and in terms of the algebraic expressions, it's very, very important, guys, because all these little components that we have just discussed will be merged together in order for us to start the factorization process. So if you go over here, I've designed some questions here that we're going to be going through step by step, and with these examples you'll be able to understand the fundamental aspects of factorizing any given expression. So let's kickstart here. Now, remember earlier we said that factorize, well, earlier we defined what is the HCF, but what exactly does it mean to factorize? In its simplest form, without using a definition from a textbook or a dictionary, my way of explaining this to my students is that whenever you see the instruction or the verb factorize, it means you're taking out the highest common factor, or you're taking out a factor from the expression, and then you are going to be writing back what is left after you've taken out a portion or a part of the expression. Now, from the textbook, the word factorization means you're going to be taking out the highest common factor, and you're going to be using the highest common factor to divide into the original expression so as to know what is left. Now, advanced or intermediate level students will understand the basic application of the laws of indices. Rule number 1 and rule number 2 that states that when you're multiplying, you add the powers. When you're dividing, you subtract the powers. Now, because of the type of students that I teach and the level of students that I teach, my language is a little bit different. So if you're an advanced student and you're watching this video, then of course be very mindful that the language is just to try to articulate as best as I can so that it's easy for every and any level students. Now, when we look at the first example here, 7x squared y take away 14x cubed y squared, and the instruction says factorize the following. So what this simply means is that I need to look for the highest common expression, and that is I am looking for the highest number that goes into 7 and into 14, which from the previous slide you'll see that the HCF here is 7. And if we look at the x's, we realize that there's two x's, one on the left and one on the right. So we have an x squared and we have an x cubed, and like we said before, when you're factorizing a expression, an algebraic expression, it has to be the expression with the lowest power. It can't just be a random x. It has to be either this x here or this x here, and in this case it has to be x squared. Now check to see also which of the y's, well, sometimes we have to check to see if the y is common. Now, just in case you guys do not understand what it means by a common expression, it means that the expression must be on the left and it must be on the right. If it's on either side, then you can go right ahead and factor it out. If it's only on one side, then it cannot be a part of the HCF. So therefore then we're gonna grab y, because we have y to the 1, we have y to the 1 here, and we have y squared. So y to the 1 is smaller than y squared. Now, taking out the HCF means that we're taking out the highest common factor from this expression here, and we're also taking out the highest common factor from this expression as well. So therefore then, the best way to look at this then, guys, is to say that 7 into 7 goes one time, x squared into x squared goes one time, and y into y goes one time. So we have 3 ones, which means that that is 1 multiplied by 1 multiplied by 1, which in this case here is 1. Pretty much what we're saying then is that 7x squared y divided by 7x squared y is very similar as if I'm asking you what is 10 divided by 10. And we all know that 10 divided by 10 is 1. Therefore, 7x squared y divided by 7x squared y equals 1. Now, fun fact, this is the only time that you're perhaps going to have to write the numerical value 1 in an algebraic expression, because most times when we write 1, it's just for emphasis purposes. Usually, whenever we write a letter like x, we already know that the coefficient of x is 1, or the coefficient of a or the coefficient of y is 1. So we usually don't write 1. In this case, we have to write the 1 because there is no other variables left over, and there has to be a value that needs to be written down there, right? And we cannot say 0 because there is no number that divides into another number and goes 0 times. So therefore, that's why we write that 1. So hopefully that is clear for you then. So if we can go ahead then and move to the second term, then we're going to say 7 into 14 goes 2 times. And now notice here that for an intermediate, even slightly below an intermediate level math student, still know that x cubed divided by x squared. Watch here, guys. X cubed divided by x squared goes x times. So most persons will know that. But remember that I teach a set of students that are doing crash course mathematics. So therefore, whenever I say x cubed divided by x squared, You might get a little bit confused. So the easiest way for you to interpret this is to say to yourself, there's 3 x's in the expression at the top here, that is this expression here, and there is 2 x's that was extracted from those 3 x's, so only 1 x is left on the inside, right? And then of course we have y squared here, and there's 1 y outside, so there's only 1 y left on the inside. Now remember guys that when you're doing your exams, nobody has access to your thought process. So depending on the language that you use, depending on your mathematical language, you use whatever language makes it easier for you to understand, because you're not asked on the exam paper to write down your thoughts. You use whatever thought process, whatever is easier, whatever language you hear your teacher using, you can use that language to your advantage so as to get you to the correct answer. All right, so pardon me if you are an advanced or intermediate level student. Sometimes there are certain topics, for example, we don't have the luxury of the time to go through topics like indices. We have to touch a little bit and we have to move right along, because we are trying to complete a 2-year syllabus in the space of 8 months. That's a very difficult process in order to get students to comprehend the concepts clearly. So with videos like these, you can watch and you can really advance your skills in a short space of time. So let's move on to example number 2 here and speed up the process a little bit. We don't want to be here for too long. So next example here, we have 12a minus 12a squared b. Now this catches a lot of students. And I've been teaching maths for 13 years. So I've seen it all. I've seen students fall by the wayside when it comes to these questions. The nerves, the pressure, the anxiety gets to students. You've got to remain focused, guys. And remember that the instruction is very, very simple. The instruction is to factorize, which literally means you're not able to subtract or add the terms. So for a student who may lapse in concentration and say 12a take away 4a squared will leave us with 8ab, that kind of stuff. I've seen those kind of answers on papers. I've marked exam papers before. It's crazy. That's like the worst answer that you could possibly write down. I always advise my students that, and this is a very bad advice, pardon me, but if you're going to destroy the question, it is better you do not answer the question. I would rather you not answer the question than you write an answer like 8ab, right? When the instruction says to factorize. So let's get into exactly what needs to be done here. Factorize means I need to find a common factor between the numerical values and the algebraic expressions. Now, for 12 and 4, it is evident that 4 is your HCF. Now, it's very important, right? Regardless of how experienced you are, you want to check to see if the variables are repetitive. So we have an a, which is a to the 1 here, and we have an a squared. So a1 is smaller, or a1 has a lower power than a2. So therefore, a1 or a is your highest common factor. Now, trick question here, check. You can see that b is on the right, but it's not on the left. Therefore, b is not a common factor. Then you're going to open the bracket here. 4 into 12 goes 3 times. A cancels a. A cancels a. Or a goes into a 1 time. 3 times 1 is 3. So because we know that it's just going to say 1 times 3, we just simply say a cancels a. That's the language of the Caribbean. That's the language of the Caribbean. We just use the word cancel. But technically, it doesn't cancel. It literally goes into a 1 time, or a goes into itself 1 time. Put it on the minus sign here. We say 4 cancels 4, or 4 into 4 goes 1 time. And then we say there's 2 a's at the top here, and we're going to extract one of those a's. That means we're going to have an a left on the inside here. And since that b was not a part of our HCF, then the b is going to come back down here. We're going to close the bracket, and that becomes our final answer there. All right, now there are I believe I'm assuming that there has to be other videos out there that are much shorter than my version of the videos, and there must be other videos there that may be a little bit more clearer than mine, but because of the nature of the students that I teach, considering that a lot of my students have a lot of gaps in their fundamental aspects of math, hence why I have to elaborate so much. So if you find that my content is in fact clear as crystal and it is suitable to your style of learning, do not forget to leave a comment down in the comment section below. Leave a like. And do not forget to share this out to someone who you know may be struggling with this aspect or other aspects of mathematics. Let us continue as we go into more advanced versions of factorization by the HCF. Now here we have a very similar example, but this time now we have the repetitive letters. Well, this time it's very similar, very similar to the one that we just did. So let's hop into this one here. Now we have HCF of 15 and 30. Here's an example where the actual number that is in the expression is our HCF. So that's 15. Now you notice here that P is repetitive. There's a P here and there's a P here. So therefore that means that P is our part of our HCF. All right, now I've already opened my bracket because if you notice here that there's a Q here, but there's no Q over here. So Q cannot be a part of your HCF. Now, 15 cancels 15, as we've been saying previously. P cancels P, so that's simply going to leave us with Q in the bracket here. And so, of course, 15 goes into 30, goes 2 times, and P will cancel the P on the right, so there's nothing left. Close the bracket, and our expression has been factorized. So, example number 1, 2, and 3 are what I would say typical CSEC structured type exam questions. Typical examples that you will find on an exam paper. But of course, sometimes, like I said, depending on the level, depending on the type of student you are, do you practice a lot? Do you find yourself doing worksheets from off the websites? Are you that type of student who might encounter variety different types of questions? So of course you might see an example like this one here where we have 18p cube 18p cube q squared plus 27p squared q cube minus 36p to the fourth q cube. So same procedure, nothing changes, we just have a variety of powers. So we're going to be checking the numbers first. We have 18, we have 27, and we have 36. We're looking for the highest number. Now notice here that 18 can go into 36, but it doesn't go into 27. So that tells me therefore then that my HCF has to be a number slightly lower than 18. So I'm going to be checking half of 18, which is 9. And if I check correctly and my timetable is up to par, I will confirm that 9 is in fact the highest common factor or highest numerical common factor here. So I'm going to pull out 9 here. All right, so let's check to see if all the P's are repeating. We have P3, we have P2, and we have P4. Just as we've been emphasizing in the previous examples that the variable with the lowest power has to be your HCF. So in this case, P squared is your HCF. Now we have Q squared, we have Q cube, and we have Q cube. So there's 2 Q cubes and 1 Q squared. Evidently then Q squared is lower than the 2 Q cubes. So therefore then 9P squared Q squared is our HCF. Open the bracket here, where we can move on to say 9 into 18 goes 2 times. P squared into P cubed will simply go P times because there's 3 P's at the top. We extracted 2, so 1 is left on the inside. And evidently then the Q squared that was at the top was extracted on the outside. So pretty much no Q's is left on the inside, or generally we just say Q squared cancels Q squared, or Q squared into Q squared goes 1 time. 1 times 2P is 2P there. All right, so we're going to be plus here. 9 into 27 goes 3 times. P squared that is here beside the 27 gets extracted on the outside once again, so no P's is left on the inside. And then we have Q cube, that's 3 Q's at the top. We extracted 2, so only 1 is left on the inside here. minus then 9 into 36 goes 4 times. P4 divided by P2 basically leaves us with P2 or P squared. All right, 4 P's at the top, 2 was extracted out, 2 is left on the inside. And finally then we have Q cubed, that's 3 Q's at the top, 2 Q's on the outside, therefore we have only 1 Q left on the inside, and our expression has been completely factorized. Ladies and gentlemen, we're going to be moving on to 2 last examples, right? And these examples, like I said, are not anything different from the ones that we've been working. It's just going to be a little bit trickier in terms of choosing the highest common factor. We're in fact going to be emphasizing the importance of choosing the highest common factor, because sometimes you can find yourself choosing a common factor but it's not the highest. And so when you choose a common factor that is not the highest, then you're going to lose some marks by CSEC, because they usually always say factorize completely. So if the question is worth 2 marks, you're going to get 1 because it's not completely factorized. Please do not forget to hit the like button, guys. Leave your comments if you find this video very simple, educating, very elaborate, very clear for you to understand. If you had problems with factorization, or you missed your last factorization class by your teacher and this video was able to get you up to speed, do me the favor, guys, and share this video out to your math communities. Share this to a friend, share this to a parent, share this to a family member out there that's wanting to do math, scared of math. Let them know that this video is very, very helpful. It really does help the channel to grow. We are almost at 600 subscribers, the road to 1,000. Let's get to 1,000 subscribers by the end of CSEC exam on May the 9th, 2025. Now, final 2 examples here. We have 81x to the 4th y cube minus 27x cube y squared. Now, I've given this example to my students, and majority of my students have chosen 9 as the HCF. And so a lot of the students, once they choose 9, they normally take out the correct common factors, leave right back what is left, and then they get what is a question mark. So they ask, sir, why am I incorrect? Because there is a number higher than 9. And so because depending on the level of your timetable, depending on how large your timetable span is, then you might find yourself choosing a common factor instead of the highest common factor. So in this case then, your HCF is going to be 27. So 27 is your HCF. Once again, we have x4 and we have x3. x3 is your lowest expression. Well, it's your expression with the lowest power. We have y cubed and we have y squared. So y squared is your lowest common, your highest common expression. Open the bracket here. 27 goes into 81, goes 3 times. x4 divided by x3 leave us with x times here. And we have y3 divided by y2, and that's going to leave us with y times here. Subtract. 27 cancels 27, as we've been seeing previously. X cubed cancels x cubed, as we've been saying previously. Y squared cancels y squared completely. So do we write a 0 here? Obviously not, because there is no expression or numerical value that when divided by itself will give 0. So therefore, the obvious answer here is going to be 1. This is very similar to example number 1 that we had up here, where we said 7x squared y divided into 7x squared y goes 1 time. So this sometimes will catch a students off guard, and I've seen where students have actually just written down, once they realize that nothing is left, some students will literally write down like 0, or some students will actually go ahead and do something like this, leaving out the second term. Remember that the amount of terms that is in your original expression should be the same amount of terms that is written in the brackets then. So therefore then, we're going to find our answer here to be minus 1 here. All right, and then of course this is something that I took from the textbook, ladies and gentlemen, boys and girls. This is something that I took from the textbook. I've never really seen an example like this on CSEC. So sometimes, depending on the student, if you're an inquisitive learner wanting to learn a little bit more about math, you might encounter examples like these in the textbook, and you might find a little bit of a challenge. So this is what we call factorizing a fractional expression then. So pretty much you just have to compartmentalize the expression by factoring the top, factoring the bottom, and leaving your answers in the brackets as a fraction. So I'm just going to take out the highest common factor for the numerator, which in this case is going to be, numerically it's going to be 3. It's going to be 3 here, right? 3 goes into 3, 3 goes into 9, 3 goes into 6. Then we have M4, M3, M2. M2 is the expression with the lowest power, all right? Then I'm going to put it over here. Look at the bottom, 5, 10, 25. 5 is the HCF. Then we have P2, P3, P4. P2 is the expression with the lowest power. Then we have N3, N2, N5. N2 is the expression with the lowest power. All right, so we open our brackets then, and then obviously we're going to have fractions on the inside. We're going to have a plus here, and we're going to have a minus here. All right, let's just write it one at a time then, guys. Okay, so let's do first here. Okay, let's do here first. All right, so 3 cancels 3. We're focusing on the top, guys. We're doing the top with the top here. Okay, so 3 into 3, 1 time. M2 into M4, or M4 divided by M2 goes M squared times, or M2 times. All right, and then of course can go to the bottom, same time. 5 cancels 5. P square cancels P square, and so it happens that N cube divided by N squared goes N times. Leave a like if you are getting the answer correct before I am. Moving right along, going back to the top here, 3 into 9 goes 3 times. M squared into M cube obviously goes M times. We've been doing that all the video here. Then we have 5 into 10 goes 2 times here. P3 here divides by P2 here. Leave us with P at the bottom here. Then N squared cancels N squared. So in expression number 2 here in the middle, we do not have an N that is left. I'm going to put a minus sign here. And finally, to close off this example and to close off this video, 3 into 6 goes 2 times. M squared cancels M squared, so we only have 2 at the top in our numerator here. Pardon me just a second here, guys. Okay, so that's minus sign. Then we have a 2 at the top here, over 5 into 25 goes 5 times. P4 divided by P2 goes P squared times. And 5 divided by N squared goes N cubed times. And we close the bracket, and we are going to be closing this video here. All right, so I do really hope that you find this video entertaining. I hope that you found this video knowledgeable. I hope that it had cleared some of the ambiguities and the skill sets that you desire here by watching this video. If you found some value, leave a like, leave your comments down below, leave some positive comments, ask your questions, and you can find links to the other videos pinned in the description of this video. Of course, you can tune in weekly on my channel. You can find me on all social platforms. All my social platforms are pinned in the description box below, and you can follow me on all social media platforms. If you need to join my online classes that I keep Tuesdays and Thursdays at Tuesdays and Thursdays at 7 p.m. to 8:30, you can subscribe by contacting me through the WhatsApp or through any of my social platforms. I'm looking forward to meeting some of you guys wherever you are in the world, wherever you are in the Caribbean. I am Apex LNU, your math guru, and your math. I'm the one that's going to change your mindset when it comes to learning mathematics. All right, and if you need some evidence of that, you can ask my current students who are currently enjoying and learning the principles of mathematics as we learn the language of the universe. Until next time, guys, my name is Apex LNU. Continue to improve and practice with consistency, precision, and focused. Until next time, see you guys in part 2. Take care. Bye-bye.